Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with Damian Brady, a marine biologist and the Agatha B. Darling Professor of Oceanography at the University of Maine. I've had the pleasure of knowing Damian for years and having the opportunity to dive into his background and learn more about his extensive work in and for Maine was a lot of fun. Damian was one of the 5-Minute Genius speakers at this past year's Maine Science Festival. I've included a link to his talk in the show notes. And I've also included a link to the paper about kelp that recently made the cover of Science. Our conversation was recorded in May 2025. I hope you enjoy it as much as I did. Damian, welcome to the Maine Science Podcast. I have had the great pleasure of knowing you for years, been a fan from afar, and now get to be a fan up close between the Science Festival and this conversation. Before we dive into your current work, which is impressively extensive, and I know there's a through line through all of it, you've got a lot of projects going on that are really cool. I was hoping you could tell us, what is it that got you into science?
Yeah, that's a really good question. So I should say, first of all, I was born in Brooklyn, New York. And so you would think anyway, exposure to nature and environmental science would be sort of limited within those confines. But I lived near a park called Marine Park. And, we had a lot of frag marsh and, I lived on the edges of Brooklyn, basically, right? And I was always drawn in that direction. And in high school, I ended up volunteering at the aquarium in Coney Island. And then I would eventually go on to narrate the marine mammal demonstrations there, 1,400 people 3 times a day, like, welcome to the aquarium for wildlife conservation. And so it was this good combination for me of science and communication, the ability to talk about these animals and why they're important and why conservation is important. So from pretty early on, I really liked where that Venn diagram of really interesting science and how are you going to communicate it to the general public. And I just sort of fell in love with marine biology and then tried to find my way into it, sort of from inner city Brooklyn into marine biology. And it's quite a journey. And I'm super glad that I ended up in Maine just because, we have 4,700 miles of tidal shoreline. We have so much ocean. We have so much riding on the ocean, right? In terms of a percent of our GDP as a state in lobster and aquaculture and energy and safety, navigation, recreation. So it was sort of the perfect fit of those two things for me.
So I saw that you went to Roger Williams University in Rhode Island. I noticed that. I lived in Rhode Island for 5 years. And Roger Williams University to me has always kind of flown under the radar. I'm curious, how did you find it? Do you know what I mean? Like, it's not necessarily an obvious choice for marine sciences. It's not like you could easily do a Google search back in the day when we were looking for colleges. But I would imagine a kid from Brooklyn would look at places in Massachusetts that are affiliated with Woods Hole, or you'd go out to Scripps or something like that. So this is just a genuinely curious question, how you found that.
Yeah, I was interested in marine biology. I was in high school. Most of the guidance counselors and folks knew that I was interested in marine biology. And there was a trip from a counselor or whatever from Roger Williams and going through high schools in Brooklyn and saying, anyone interested in some of the things that Roger Williams has to offer. Roger Williams has a great architecture program, for instance. They also have a good marine biology program. And I had a conversation with them. I applied, ended up getting a full ride to go there. I think I didn't understand what research was. So I think in hindsight, I might have said, if I went to an R1 research university, I probably could have connected into research a little bit more while I was there. On the flip side, you have the small campus feel. There's plenty of ocean around there. Mount Hope Bay is beautiful. It was a beautiful place to spend 4 years. I learned a lot. But I think it was sort of the combination of, someone wants me to go here, which is, plays into the old ego side of things, right? And it's free to go here. So that combination sort of sealed the deal for me.
Yeah, and I don't think that's trivial. Are you the first in your family to go to college in the US?
I am, yeah.
So that's a huge deal, right? And to have that. But also, I think it's really interesting to take yourself out of the city and go to a really different cultural place and navigate that. Anyway, I have a fondness for Rhode Island.
Yeah, me too.
So marine sciences, you might be the first person I've ever talked to who found their passion in science at an amusement park. That's pretty great. So you got to Maine, which I agree with you, like for a whole bunch of reasons, including the ones you listed. It feels like hitting the lottery in a lot of ways. I mentioned when we first started that you have a lot of different areas of research. People go to your lab website, and I'll put the link to that. There's, for example, a really cool picture of a lobster getting a shot, which I don't think anybody really thinks about. I don't know. We don't have time to talk about all of the different pieces, but you mentioned lobstering before we started recording. I think it's truly iconic. If you want to talk a little bit about that and maybe pick one or two other projects that you've got going, you're at the Darling Marine Center as well. So that's another kind of part of UMaine's research that I think most people don't know about. And explain, if you can do the through line, that would be really great.
Yeah, so I'll start with the through line. It's maybe sort of ironic, right? Because I find myself in a lot of controversial areas oftentimes. So let's say offshore wind, right? I've been working as the University of Maine's environmental monitoring lead for floating offshore wind since 2010, which is pretty controversial. Aquaculture and siting of aquaculture, working with companies that are thinking of developing aquaculture projects. And then lobstering, right? Lobstering is iconic. In some ways, it's the most sustainable fishery I can even think of. You know, for decades, we catch almost close to 100 million pounds of lobster every year by like clockwork. And yet it's also controversial with respect to interactions with Atlantic right whale and fisheries regulations. So the through line for me has always been decision making. So how do we make decisions about how to use this public resource, whether it's leasing for aquaculture, leasing for offshore wind? You know, who do we let use the ocean and why? Because it's this massive, massive public resource, right? That no one owns a square inch of the ocean, but everyone is permission limited. And how do we give permission for people to use the ocean? So that's the part that's the through line for me, is sort of how does science and information help the public make the best decision about one of, the largest public resource on the planet Earth, right, is the ocean. So I think that's the through line for me. I'll talk just a little bit about the Darling Center. Darling Center is celebrating 60 years, Maine's oldest marine lab along the coast here. It's got quite a history in terms of innovation and science. A lot of the fisheries management regulations that we have now that were really, really smart in hindsight, like the kinds of things we do now for lobster, like V-notching. And if you're not familiar with V-notching, every time you find a female lobster that's large and holding eggs, you put a little notch in its tail and you throw it back. So even though you could make money on that lobster, the idea is that you're throwing those eggs back in the ocean. And then the next time that person finds a female lobster and it has a notch in its tail, they will also throw that female lobster back because they know it has carried eggs sometime in the past and therefore could carry eggs sometime in the future. Having a minimum size, regulating the fishery in zones. We have 7 zones in the state of Maine, A, B, C, D, E, F, and G, that go along the coast in reverse order, which is annoying if you're like looking at a map, because A is down East Maine and then it comes down to New Hampshire. A lot of that happened here with folks like Dr. Bob Stenick, Dr. Rick Wally, and others that helped to develop the science behind a lot of those really, really good long-term decision-making. And then the other big innovation piece is aquaculture. So the first leases in the state start right here around the Darling Center. Triploid oysters, which are oysters that carry 3 chromosomes. If you've ever eaten an oyster in your life, whether on the Pacific or the Atlantic, chances are you've eaten a triploid oyster, and triploid oysters were essentially invented here at the Darling Center. So it's a little lab, the University of Maine's Marine Lab, but a huge amount of innovation in the blue economy has occurred here. And we continue to do that, right? So the largest scallop farm in the state right now, Sea Scallop Farm, is co-owned, co-founded by a Darling Marine Center student, right? So as that burgeoning industry takes off, it's a little bit like Bill Mook, who started Mook Sea Farm, from the Darling Center in oysters, right? So there's a huge legacy, I think, in that piece. And that's one of the reasons I love working here.
We're going to do a dive a little bit. So what is the significance of the oysters with the 3 chromosomes?
Yeah, so triploid oysters, they hold 3 chromosomes. And the significance there is that we're at the northern end of the range for oysters. So when people think of oysters, oftentimes they might think of the Chesapeake Bay, right? Or maybe New York, New Jersey. So we're at the northern end. And although, if you go and take a walk here near Round Top Farm and the ice cream place here in Damascotta, you'll see the largest shellfish midden in the world, I think, for oysters that are across the water there. And so clearly indigenous people have been eating oysters here for a long, long time. But a triploid oyster will grow a lot faster than a diploid oyster. So if you are at the northern end of its range, a triploid oyster doesn't reproduce. So that's the other sort of nice part about a triploid oyster, is that if you're afraid of introducing oysters into another area that it might outcompete local oysters, they don't reproduce. And so they put all their energy into growth. And that has been a huge innovation, particularly here in Maine.
And I'm going to guess that that has made people much more comfortable with having those farmed because, like you said, they can't impact the native oysters that are there.
Yeah, it's super interesting. We have a project with the Nature Conservancy now, right, where some folks want you to plant a diploid oyster so that they can restore and get more of what we would sometimes call feral oysters, which is always a hilarious term, like they were feral cats. But there is a case where, hey, I would love to restore these natural oyster beds that were here, and you're an aquaculturist and you're growing them in these cages. Why not let them reproduce and then let the baby oysters settle and to, create more recruitment, what we would call recruitment onto these traditional oyster beds, right? So I think it goes back and forth. And there's a reason that people buy some diploid seed and some triploid seed.
So what is the research that you're doing around aquaculture specifically? And are you looking only at critters as opposed to like seaweeds and kelp and things like that?
No, our group, we're pretty broad, right? So we've done work with recirculating aquaculture system companies along the coast that have popped up here, trying to grow anything from yellowtail to Atlantic salmon or American unagi, which, raising American eel. We've done a huge amount of shellfish work, primarily sea scallops, oysters, but also mussels, razor clams, soft shell clams. And then on the kelp side, right now, we're helping to maintain the deepest kelp farm in the world off of Monhegan Island that's in 100 meters of water, which has been fascinating to maintain and grow a farm out there. But the kelp is gorgeous out there, so it's beautiful. So we've done all three of those things. I'd say back to sort of the through line about decision making, one of the things that we try to do is we'll go to public scoping sessions. Aquaculture can be controversial. You're trying to lease this part of the water to grow something so that you can make money and other people might have to look out their window and see it, right? So there's controversy there. And so we try to bring oceanographic tools to help folks make decisions. Like one of the examples is a lot of folks sink their gear. So they have floating oyster bags, they sink the gear. And then the question is when they raise it up after the winter's over and they bring it back to the surface and it resuspends sediment, could that sediment end up on nearby eelgrass beds, right? So we will put sensors on their farm, on the eelgrass bed, in between to sort of measure their turbidity or how much suspended sediments in the water column to sort of help say like, oh, is this a problem or is this not? Similarly, we really, really love to take oceanographic tools like remote sensing. And one thing that's been really cool since about 2017, we have satellites Landsat 8 and Sentinel-2A, which is a European satellite that have 20 or 30 meter resolution. So just to put that in perspective, we're getting data on the scale of a farm now from a satellite, and we can tell you how much chlorophyll's in the water, how turbid the water is, what the temperature of the water is. And what makes that unique for Maine is that because Maine has 4,700 miles of tidal shoreline, we're a super jagged, super serpentine coast, which means that we really need satellites that have that kind of resolution because we have 552 estuaries along the coast. So trying to get more information into a usable format, right? It's one thing for the European Space Agency to take a picture of the coast. It's another to say, oh, this is how much food is in the water for bivalves, or this is how much turbidity was in the water. And so that's kind of like, as I said before, the through line of like, how do we take these really advanced, super cool oceanographic tools, but then make them decision worthy, which is to say, like, now you can sort of make a decision based on numbers rather than, I think that this would be a problem.
How many lab folks do you have working for you? How many students? Do you have postdocs as well?
We usually have like 15 graduate students and about 10 staff in my lab right now. And that includes 3 people that work in our water quality lab. So we take water quality measurements. So if you're afraid that your coastal water quality has too much nitrogen in it or too much phosphorus or too much chlorophyll, we can take and run those samples, for instance, at the Maine Water Quality Lab here. So we have staff that do that. And then we have staff that go in the field and collect those water quality samples. And then we have staff that almost like extension folks. They work with an oyster farmer because they've seen a disease or they have a problem in a scoping session about a question that they're not quite sure how to answer. And they'd like some information and data and instruments to sort of help answer those questions that they hear.
And then you said 10 staff, 15 students? And do the students include undergrads? I mean, you're not on UMaine's Orono campus, you're on the coast. Logistically, that makes a ton of sense. So does that make it harder to have undergraduate students as researchers, or do you grab them in the summer?
We definitely grab them in the summer. But then the Darling Center has a dorm here on campus. So students actually do something we call semester by the sea. So they live here in the fall. And then for the first time ever this spring, students also live here. Usually we would have a lot of summer interns. We would have the fall semester by the sea cohort of students, usually like 20 to 30 students. Then usually we sort of have the spring off to get everything cleaned up. But now we have a spring semester by the sea too. So we can engage undergrads basically year round now in things like work study and to get them to get their honors projects and capstone projects.
Yeah, so I mentioned that because you said knowing what you know now in hindsight, going to a research university might have gotten you on your path faster. One of the things that I've highlighted many, many times in my conversations is how much research undergraduates can do. So I guess my counter to you about not getting research started, I've talked to an awful lot of people in the span of my career who go to big, huge research universities and do not do research until junior or senior year because the culture isn't there to take first-year students and second-year students. And like, it's hard to teach those kids how to do research.
Yeah.
It's a really intensive mentoring situation.
We just had this sort of conversation because I think traditionally we've thought of freshman and sophomore year as the eat your broccoli years. And that's, sort of how we've looked at it. We said, you got to take organic chemistry, you got to take calculus, you got to take Bio 1, Chem 1. So it's almost like we said, go there, get the basics, take these classes, and then by the time you reach junior or senior year, you've eaten your broccoli and now you're ready to run. And I think that mindset is starting to change. They have to eat their broccoli and also start to get some more direct experience. And to the extent that they can eat their broccoli while they're also getting that experience, I think is the real key here. At least at the University of Maine, we're leaning into something called Research Learning Opportunities, or RLEs, where we try to take a cohort of students through it, right? Because the issue at a large R1 university is like, how do you deal with the fact that we have almost 100 incoming undergraduate students? And how do you get them the sort of individualized attention? Because the gradient here that you're talking about, which I think is a really good one, is we have assets, right? Like we have $250,000 buoys that you're not going to get at a Bowden, a Bates, a Roger Williams. Like we have oceanographic assets that are really, really big and could be useful for students to learn from. But then, on the flip side is we've got a lot of students that we're trying to move through the system. So those RLEs are really helpful because we can try to treat those early students as like cohorts rather than being like, I'm going to try to get you this individualized experience. We're going to try to get you a small scale cohort level experience.
And just to clarify, that 100 students every year is just marine sciences, right?
Correct. That's just marine sciences, which I think will probably be under that number this year, but it's one of the largest marine science programs in the country now.
Yeah, I've always thought that the marine science program at UMaine has been a far too hidden gem for far too long. And I think the work that you and your colleagues do is a perfect example of that because there are so many different types of research happening that it's easy to forget it's all part of this larger ecosystem of marine science. All right, I'm going to put you on the spot. Do you have a favorite research project, either currently or in the past, where it just hit all these things for you that, just boom, it was just amazing?
I think I'm in the midst of one right now. And so I'll give you just a slight bit of background, but let's go back to American lobster. At some points, I think it was Maine's single largest export. If you add paper and pulp, it blows it out of the water. But as a single product that we export, in addition to what it stands for in terms of our tourist economy, which is sort of the largest part of our economy anyway. And it was worth $521 million last year, right? It's a $500 million fishery. I feel like I'm not going out on the limb to say that it's the largest fixed gear fishery in the world. And, especially when you add up Canada, it's the largest fishery in the Western Hemisphere by value. So one thing that has been fascinating about being here is that landings peaked in 2016. So landings have been going down ever since, but price and inflation has sort of kept the value pretty similar, hovering around $500 million, sometimes a little bit more and sometimes a little bit less. One thing, though, that we're noticing is that up until around 2010, and I'll get into the reasons why this is, it used to be that the more female lobsters, the more what we call spawning stock biomass you had, then the more baby lobsters that we would see settle along the coast. And it was nice and linear, more females meant more settlers that year. And it takes about 6 weeks for a lobster larvae that's floating around in the water to fall down again, right? So they should be pretty linked. More females They release the larvae into the water. They float around for 6 weeks. They end up in these habitats, and we see that linear relationship for the most part. And that makes management really easy. You talk to lobstermen and you say, just leave as many female lobsters in this population, and you and your children and your children's children will be able to catch lobster. And around 2010, something breaks. And this is sort of why I say we're in the midst of something. And now you have all of this spawning stock. All these female lobsters are in the population, but we're not seeing any baby lobsters. And you sort of watch this curve go up, and then post 2010, it just goes down the other side. And it's fundamental, right, to one of the largest fisheries in the world. And then now all of a sudden you can't tell lobstermen if you save all these female lobsters, you're going to see baby lobsters. And it usually takes that baby lobster, once it's settled onto the bottom, 5 to 8 years to get to harvestable again. So it turns out to be a really good crystal ball that if you don't see these baby lobsters in 5 to 8 years, there's going to be something wrong in the fishery. So roughly in 2010, something changed. But the settlement that was happening, which was good, gets caught in 2016. So it's about 6 years later, we peak in landings. And then ever since then, the landings have declined. I remember giving here's my plug for the 5-minute genius. But that's why I think this is so important to try to understand what happened to us in 2010. Because clearly something happened to us and something's happening to these larvae. And there's sort of two dominant hypotheses. One is that with the warming Gulf of Maine, there was less Calanus finmarchicus, less food for those baby lobsters. So in the 6 weeks that they're floating around the water column, they have to eat something. And so there's one hypothesis that said they're being starved in this hotter water. And so even though there's a lot of female lobsters sending a lot of larvae into the water, they're not surviving to settlement. And then there's some evidence too that circulation has changed and that female lobsters are going further and further and further offshore and releasing their larvae into water that essentially exports a lot of the larvae offshore where they don't successfully settle. So some combination of the warming causing female lobsters to go offshore, or that those baby lobsters are dying in the water column, is causing this potentially big problem in the future, right? As we sort of begin to decline in landings. And then the last piece of the story is the last 2 or 3 years, the Gulf of Maine has started to cool a little bit, right? Which is a really tough sell when you're saying, hey, there's climate change, the Gulf of Maine is warming. But guess what? The last couple of years has been cooling. And that's mainly because we're at the mercy of what water comes in from the offshore. So sometimes that water is really, really cold. Sometimes it's really, really warm. So we have this long-term warming trend, but ensconced in it is going to be periods of cooling, right? As we move up and down this sort of larger line. And it's a classic climate communication problem to say, sometimes it can be cooling and we can still be in climate change, right? But one thing we're noticing is that settlement is starting to go up again. Calanus might be starting to return to the Gulf of Maine. And so the big question for a fisheries manager, right? And I was having this sort of the conversation with the folks at the Department of Marine Resources. What do you do when you have these like little periods of cooling that might give you a little bit of boost, but you're overall in a situation where sometimes it's going to be a really, really good idea to protect as many spawning females as possible. And then sometimes it's not going to work that way. And so even though you put together the best fisheries management plan you can, the most sustainable fisheries management plan you can, climate might have other ideas. And I think that's what I'm super excited about right now, is trying to figure out that, oceanography, to the biology of this organism, to the policy, to the social side of like how fishermen react to this information.
Do you think there will be enough cooling happening that you and the people looking at this will get a definitive answer about what's going on or not?
Yeah, it's a good question, right? We really do need to get to narrow down these hypotheses, right? I think there are some other competing hypotheses out there too. And there can oftentimes be what we call density dependence, right? So the density of lobster could be so huge that there's some responding force to bring it back down again that we're not accounting for. So there's a place now for some more mechanistic studies, right? Where we go out and we try to capture Calanus and lobster larvae at the same time. And there is a student named Alex Asher who's looked at the guts of lobsters and used environmental DNA to find out how much Calanus was in the gut of a lobster. So you can just imagine like a really, really, really tiny lobster larvae, and then being able to take material from the gut of that lobster larvae and say like there was actually Calanus inside the gut of this lobster larvae. So there's some really, really cool tools that will, I think, help us winnow down this hypothesis in the next couple of years.
Well, this is a good segue into what I told you before we started recording that I wanted to talk about. I think it's really important in this day and age to not just talk to people who are doing really cool science. One of the things that I get to experience that no one else gets to experience is to see your face light up when you talk about things. Since this is an audio podcast, I love talking to people who are deeply engaged with their work. And that's kind of one of the points of this podcast, is to get that point across. But I don't think right now that we can talk about science and how it solves problems for us or it helps us figure out the world without talking about the value and the importance of long-term thinking and sustained research and research funding. And this is why it's a good segue. The lobster industry. The lobster fisheries really is extraordinary from the perspective of using science and using knowledge. It's real long-term thinking. So I want to give you the opportunity to explain why research funding and grants that allow for basic research to inform decision-making, like why that's so valuable. It's something that we need to have a long game vision, I guess, is what I'm getting at.
Yeah. The whole nature of the lobster fishery, it has purposeful inefficiencies in it. For instance, a trap fishery. I'm going to go out and put out a trap. If I really just wanted to collect the most amount of lobsters I wanted, this would be a trawl-based fishery, right? And I would just rake the bottom and pick up the lobsters over time. But the slow play here would be to put out traps, wait around, go pick up those traps a couple of days later. And look how that has sort of engineered the system, right? So now I put a pound of lobster in every trap, and every lobsterman on the coast has about an 800 trap limit. And every 800 traps, there's 5,000 lobstermen, right? So I can take that and multiply 5,000 by 800 and, multiply by a pound of bait in each one of those traps. And all of a sudden, I'm feeding those lobsters, right, to some extent. So any lobster who can get in and then get out through one of the vents is fed. And then, of course, adding the fact that lobstermen are often throwing away money. They're throwing the V-notched females in. We have a max size in the state, so they throw really big lobsters back, much to their chagrin, because Massachusetts doesn't have the same, or Canada doesn't have the same. So sometimes they're throwing it back to help themselves and then also shaking their fists because someone else might be able to catch that lobster later on. But they do it, right, because of their children and their children's children, which is one of the reasons I love going to the Fishermen's Forum in Maine, because it's such a super unique meeting, largest gathering of fishermen, I think, on the East Coast. But you see these 13-year-old apprentice lobstermen there, right, like that are dressed like mini lobstermen walking around there and saying, like, this is the reason that they have these measures in place. And I think similarly with the A, B, C, D, E, F, and G, the territory is split. And then within each of these A, B, C, D, E, F, G, they have lobster zone councils that help them make decisions and figure out territory. And so the governance has been distributed. The way that their fishing is distributed. And the reason that I think that that's been so important is that for a long time, the lobstermen and the scientists were really, really thinking hard together in a room, which was really, really important. And then the last piece, in 2022, the University of Maine starts something called GOMOOS at the time, the Gulf of Maine Ocean Observing System, which is a great name. And we started putting buoys out into the water. And those real-time buoys, when we first put those in the water, there was 10 to 12. Now we have only 5 functioning buoys that are out there in the water. So it's been eroded every time. But when I sit down with lobstermen, the first thing they say is like, I check buoy F every day. I get up in the morning, I look at buoy F, I look at the wind and wave conditions, and then I decide whether I'm going to go out or not. And that information is information they're using every day. That's the information that, when someone says the ocean observing systems are going to be zeroed out in the president's upcoming budget, where you say, that is a real problem for people that are working on the water. And I recall this story that the world's deadliest catch, the fishing show that was out, was thinking about coming to Maine and doing a piece on the lobster fishery. And when they heard that essentially the fishermen look at the buoy and decide, like, I'm not going to go out, it wasn't dangerous enough. And it wasn't dangerous enough because of the information provided by NOAA and the Ocean Observing System and the University of Maine and the fishermen all working together to figure out where these buoys should go, what they should measure, at what time points they should deliver that information, so that we could create both a system that's safe, but also a system that helps us monitor the Gulf of Maine. There's nothing about the story I'm telling you about this sort of regime shift where we had a Gulf of Maine before 2010 and after 2010 that doesn't come from the buoys that give us that information. Because even just trying to use satellite information, you need a buoy to ground truth that, right? To tell you you're not crazy. To actually have a thermistor in the water, like measuring the temperature, turns out to be a really, really important thing. So I think that's the confluence right now is we have a really, really sustainable fishery where we can catch lobsters at the rate we need to support 5,000 jobs plus the thousands of jobs behind them on the processing and dealing, plus the thousands of jobs in the tourist economy. All of that is built on having these data streams that are supported publicly. When I see reports about things like Maine Sea Grant getting terminated or reports about the ocean observing system being zeroed out, I was like, there's so much of our infrastructure along the coast here that's built on having sustainable information streams that it's almost like water. Like we can't even imagine life without it. And just even thinking about it without it, I was like, how could this even happen without this?
Yeah, and I think our listeners who actually are not from Maine, the importance of throwing the lobsters who have the eggs, the V-notch and the maximum size, people might wonder why the maximum size. My understanding is that, first of all, lobsters have a much larger lifespan than people realize. It's decades, right? If they're left alone. But also the older the females get, in contrast to many mammals, the more eggs they produce. Do I have that right?
That's correct. Yeah. Most of our what we call stock assessment, right? So how many lobsters do we think there are out there? We assess that. We call that stock assessment. A lot of it is essentially leaned up against that we think that there's a lot of large females that are sitting there offshore that are a huge part of the production cycle.
Yeah, and we only know that because of the research that was done 40 and 50 years ago, right? Like those parts of it.
Oh, for sure. Yeah.
So the part that I have always found really fascinating, and I don't know what the answer is, obviously, because if I did, then you guys all would have figured it out, is the difficulty in having this incredibly great sustained fishery built from lobstermen and scientists working together and knowing south of them and north of them are fisheries that are not doing the same thing and impacting what happens in Maine. And I'm just curious, what do you think it would take to have a more regional approach? Obviously, I think the Maine fisheries approach is the best, not because I live here, but because it's grounded in decades and decades of science and collaboration. Do you see any way that we could look at things more holistically in the ocean in that way?
So Maine is unique insofar as we're also transboundary, we're also international, right? So if you want to have a more cohesive or holistic fisheries management plan, you have to work with another country. So this came up in a very big way this year already. We're in the midst of a stock assessment situation here. And because landings peaked in 2016 and landings have been declining ever since, fisheries management is saying, well, we should do something, right? We shouldn't just watch this trajectory. We've all watched fisheries get overfished or decline and collapse. We should do something. And so they started to look into conservation measures that they might try. And one of them on the table was, let's increase our minimum size. So instead of an 83 millimeter carapace lobster, which is really your pound-and-a-quarter lobster you go pick up at the store, we're really, really good at this. As a state, as soon as a lobster hits 83 millimeters, we catch them, right? And that's your pound-and-a-quarter lobster. So they said, well, let's make it 86. And so now you're going to go to the store and see more pound-and-a-half lobsters, maybe potentially, or still a lot of pound-and-a-quarters. Again, 3 millimeters sounds like not a lot. It's not huge, but it would leave more spawning females in the population that were a little bit larger. And the models are good enough that, now I can have a little slider and move it over 3 millimeters and say how many more lobsters will be in the population. And obviously it's unpopular with fishermen to say, now you're going to throw away, especially in the first year, you're going to throw away a bunch of these lobsters that you normally would have brought back and gotten money for, but now you can't. So it was unpopular, but traditionally, V-notching and max size and the initial 83 millimeters, there's pain in the beginning, but long-term thinking can win out. One thing that I think a lot of us learned as a result of this is that one of the results of climate change is that the lobster industry is exploding in Canada. It used to be 40% of the lobsters were caught in Maine in the United States and maybe 60% in Canada. And now it's much closer to 70-30. And so Canada wasn't interested in changing their gauge size at all. And even though we catch a lot of lobsters in Maine, we import a lot of lobsters into the processing facilities that are here. And then it would be illegal, of course, then for you to bring in these 83 millimeter carapace lobsters from Canada into the US. So it basically became Canada wasn't interested. And therefore, Maine basically said, well, we have to step back from this, right? Because if Canada's not interested, and we can't move lobsters back and forth across the border freely. And of course, there's a whole tariff issue too, right, to throw on top of that. But I just wanted to underscore your central point is I think it would be great to have a more holistic and regional approach. And we do in the US to some extent. So some of the states, obviously, like Massachusetts, have different regulations than we do. New Hampshire, which primarily fishes offshore, maybe a little bit different rules there too. But it's going to be really, really hard when you have not only these sort of state level and regional differences, but then you have this international border that you're also dealing with.
Well, I appreciate you confirming that it's just a really complicated question and makes the work that you and your team are doing with the tools and the decision making and the through line, I think, all the more relevant. You are doing a long game, and that can be really frustrating and hard. So I want to thank you and your team for doing that. It strikes me that you have enough projects going where you get small victories and small bits of knowledge that it helps build up this idea of what's best next. So we're going to leave it at that. I could actually keep talking to you for hours and hours, but you've been so kind with your time. I don't want to take too much advantage of it. So I appreciate all of this. I appreciate your work. I think I'm going to be even more interested in following how we deal with these types of things than I already have been. So thank you so much.
Hey, can I add one more tidbit?
Oh, please.
Or at least a little piece of audio, because this may or may not come out in the next week or two. But we have a paper that'll come out in Science in the next 2 weeks. I'm really excited about it. Maybe it's the Monty Python now for something completely different, but it's about kelp and kelp beds. So we have kelp forests in the Gulf of Maine. Sometimes people don't realize, like, oh, we think of kelp forests in California, right? And surface forming kelp forests. So Dr. Doug Rasher and myself and students from our lab, particularly Shane Farrell, have been doing these surveys on these kelp forests along the coast of Maine. And we noticed that kelp forests in York County in southern Maine are collapsing, and the kelp forests in down east Maine are still very, very healthy. And a lot of it has to do, again, with the oceanography that we've talked about, right? We have all this water that comes into the Gulf of Maine, sort of into the Bay of Fundy, into the eastern Maine coastal current, and it remains very, very cold because that water is basically very deep water that's come up to the surface for the first time and creates this very, very cold down east Maine, and then it sort of warms as it makes its way along the coast. Traditionally, when kelp forests fall back due to potentially high temperatures and poor recruitment, there is a red algal turf that grows there instead. And it's low-lying, it provides poorer habitat. One of the things that Shane Farrell has found is that if you take a super soaker, literally like dive, take a super soaker, suck up the water that's right above those red algal turfs, and then you try to identify the chemical mixture that's in there, he found like 17,000 different chemical features, of which we only understood 2% of that, has been identified before. And then if you take that water and you expose really, really baby kelps called gametophytes to that water, they all die. And so one of the fascinating things that Shane is finding, and then this paper is going to talk about, is that sometimes you have these climate-induced effects that reduce a kelp forest, and another species comes in and then basically uses chemical warfare to never let the kelp settle back onto those environments again. And so it's really big implications for conservation. Even if we were to reverse some of the effects of climate, it could be hard for some of these species to reestablish, and we sort of get locked in this other state of existence. So I just wanted to throw that story out because it's going to be a fascinating story to sort of see how it unveils. And when you had asked me before, like, what am I really excited about? I was like, how did I not get excited about the science paper that's coming out in a week? So I put that marker down too.
This is great. And this is why I could keep talking, because we haven't even touched things beyond the lobster part, just because that's fascinating. We will definitely include a link to that in the show notes. We're going to come back to this, Damian. I'm going to rope you into talking to me again in another year or two so we can follow up on this. Because it's the amount of things that we don't know in the ocean, and the idea of the 17,000 chemicals is really an extraordinary reminder that we just still have so much to learn.
I'll forward you the paper when it comes out, just to see how little we understand, right? Is fun.
Yeah, and the algae part is really fascinating because Maine has not been subject to big algae blooms. That seems to me is foreshadowing. I talked to Deb Bronk years ago, and she had, done a bunch of work in the Gulf of Mexico and in Virginia area, Chesapeake Bay. And one of the things that she had talked about back then was how pure and pristine Maine was, and it hadn't suffered a lot of those things. So it's interesting you guys seem like you're right on the crux of really seeing a big change in that. So really great research, really, really fascinating. I appreciate it. Thank you.
No, thank you, Kate. I appreciate the opportunity.
Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by following us on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is executive produced and hosted by me, Kate Dickerson, and edited and produced by Scott Loiselle. And the Discover Maine theme was composed and performed by Nick Parker.